start here. So thank you so much for allowing us the opportunity to sponsor this conference and give us a short, allow me to give this short presentation. Again, my name is David Shahon. I'm the regional manager for CT Northwest. Okay, CT Northwest has been a supplier of equipment since 1996. Most notably, our founder was instrumental in bringing video detection to the US with the Traffic-On product, now owned by FLIR. Since merging with Control Technologies, we have expanded our portfolio to include many more manufacturers and products to help our clients. Our goal is to ensure we have the right products to meet the future demand of agencies in the Northwest. Here's an example of a few of the manufacturers we work with. All are leaders in the products they bring to market in the US and globally. As a side note, if we look towards the future, all of these manufacturers make technology that is available today for connected vehicles. Two of these manufacturers make ADAS sensors for vehicle autonomous driving. So what solutions will we need in the future? Of course, I don't have the answers, but what we do know is that there will be changes to the infrastructure. There will be more emphasis on vulnerable road users, bikes and peds. There will be more emphasis on transit and rideshare, and a new emphasis on toll lanes, maybe even road usage charges. How long before vehicles are connected? Will they talk to the infrastructure reliably? Will they talk to vulnerable road users? And how do we create a more reliable network? We know we'll need to add both roadside and vehicle mounted radios. We need to communicate locally between the infrastructure and vehicles as well as centrally over a cellular network. But how reliable is our network? Is a fiber connection enough? Do we need to also consider cellular modems like this Digi modem seen in this picture, that we can also be a redundant backup, sitting idly unless there is a communication breakdown? We need to make sure that we are not relying on a single point of communication between the signal and connected users. I want to play this video showing how one manufacturer can protect vulnerable road users using both in-car and roadside equipment that works together seamlessly. As you can tell, that's a marketing video, but I think it's pretty good. It sort of shows how the in-car receiver sees the vehicle that's being tracked by the roadside sensor. So how does this technology fit in? Can we install hardware today that is ready for tomorrow? What if we leverage the best technology, say a thermal sensor, with artificial intelligence and identify all road users, including bikes and ped? Now we have the most accurate detection of all users, including classification. Notice the detection AI even recognizes receding traffic. I'll wait just a second. There we go. There's the video playing, and hopefully you can see that. Receding traffic being recognized, classified, identified, all that with today's artificial intelligence. How about if we go a step further? Here we take highly accurate radar detection from Smart Micro and combine that with AI video analytics from a company called DIRC. Here we can get stop bar and advanced detection, lane by lane, and counts, classification and turning movement counts, and also include detection of safety events. So I'm going to use our demo site here in Washington, and you can see, got to get to this here. You can see from this video that the detection of vehicles is combined with video display, and it shows that we are able to collect both vehicle and vulnerable road user counts. As seen in these graphs, this data can be displayed by day of week, movement, or user type. As I bring up this video, the video, you can see the identification of unsafe road users, like wrong way drivers. These are drivers entering a fast food restaurant. At this site, since June, we have identified over 800 jaywalkers, over 40 vehicle-to-vehicle near-miss events, 15 vehicle-to-vulnerable road user near-miss events, and over 2,100 wrong-way drivers. The DIRC system added to the video feed has been very interesting, to say the least. The data collected is very useful for future design and safety. A couple more videos here, I'll let this play. I find it very interesting to see how people use the roadway or misidentify what they're doing, or in this case, turn at the wrong time. One more clip I think is interesting. Don't know where he was going, except to the restaurant there. All right, if I move on here, what if we added, say, a roadside unit to that demo site? Now we can leverage DIRC's ability to build a J2735 connected vehicle message and broadcast that locally. This video shows the code, which is identifies the location, speed, trajectory of the pedestrians and bikes as seen in the videos. If we take that information and we broadcast that, would allow us an appropriate connected vehicle to see where those users are, hopefully influence proper driver behavior. Eventually, this will be necessary for autonomous vehicles to see beyond their sensors and know what is coming before they get there. All vehicles manufactured from 2024 and beyond will have connected vehicle infrastructure. What if we leverage DIRC's video analytics to influence the operation of the signal controller? Can we hold the all red for a red light runner? What about pedestrians in a crosswalk? Can we extend an all red for a slow moving pedestrian? In this video, the FLIR thermal sensor is detecting that the pedestrian is still in the crossing when the signal is supposed to change, giving the oncoming traffic a green ball. However, we are communicating this to the queue-free traffic controller, and we add 10 seconds to the all red, allowing him to get across safely. Drivers are unaware, but the pedestrian can now cross safely. Can we terminate a crossing too early if no one is there? What else can we do to improve both traffic flow and safety? If we know a pedestrian is waiting, we can hold a right or left permissive turn. We can initiate an advanced walk to protect the pedestrian, giving them time to enter the crossing and be visible by a turning vehicle. What if we focus on roundabouts? It's kind of becoming a favorite here in the Northwest. So, since there's no signal, they are safer. Vulnerable road users are more protected. Users know how to use them effectively. On this particular intersection or location, in the last 30 days, we have identified 60 jaywalking events, 13 vehicle-to-vehicle near-miss events, 15 vehicle-to-vulnerable road user near-miss events, 8 wrong-way drivers, and over 9,000 lane adherence violations. One more interesting clip here. This goes to show you need to be careful when you're entering a roundabout or exiting. Tomorrow's solutions are here today. If we can bring these technologies together, allow one operation to influence another, we can improve the operation of the signal, improve vehicle travel. We can make the signal safer. Will that get us closer to Vision Zero? What if? So there's a lot more that I can say on this subject, but I wanted to get a short presentation out to all of you. If you want to talk more about this or other technologies ready for tomorrow's needs, stop by my virtual booth or give me a call.
Thank you, David. Much appreciated. There is, if you do have a question for David and didn't have time to ask it, just put it in the Whova session. And we can actually, David can go in there and he will type an answer to you. I know there's at least one in there.
So I actually see that question, and yes, we can configure things to count U-turns and close calls, and that's all part of it.
Perfect.
Absolutely.
Thank you, David. And if anything else pops up, feel free to reach out to David. You can message him through the Whova app.
Thank you for having me.
Bye.